Hi everyone, my name is Fahim Tonmoy. I work as an associate principal engineer at BMT and also an adjunct research fellow at Griffith University. We have been working with Cairns Regional Council and in collaboration with TUD Lab at James Cook University to investigate uh, some urban heat management strategies for Cairns CBD area. Today I'll talk a little bit about that project, and also while doing that I'll emphasize the importance of using an evidence-based approach to manage urban heat under a changing climate. So the concept of urban heat island is not new at all. It was first talked about by Luke Howard back in 1800th century when he identified that nighttime temperature of London was about 2.1 degrees Celsius warmer than the surrounding countryside. And since then, the concept has become more critical as cities grown bigger and more people have started to move into these cities. At the same time, climate is changing. In last 40 years, we haven't seen a single year where temperature was below average, and this trend is not likely to stop anytime soon, as reported by IPCC's sixth assessment report. And we can expect a 4 to 5 degrees temperature increase towards the end of the century. And if this average temperature increases, then that will increase the intensity and frequency of extreme heat wave events. So heat wave event that we used to see only 1 in 50 years previously will happen about 10 to 15 times more frequently in near term, and towards the end of the century it is likely to become an annual event. And this has significant impact for our community's health and well-being. Heatwave is a silent killer. Since 1900, more Australian has been killed by heat wave and heat-related complications compared to all other natural hazards combined. In this figure, one person equals to 100 deaths, and you can see the scale of difference between heat wave and other extreme events. And this is just present day heat conditions, and under future climate conditions, this is likely to increase further. So you can see why managing urban heat is becoming so critical. And as a result, some works are already underway. Often tree plantation is seen as a low-hanging fruit for managing urban heat, and that's why major cities across Australia have started to release their urban greening strategies, and which also includes Cairns, where Cairns has released their tropical urbanism policy. But tree plantation is not the only solution of managing urban heat, and there are other innovative solutions has been designed and trialed in the engineering and planning space. A number of them includes water-sensitive urban designs, cool roof, green roof, and cool roads. And these has been trialed in different parts in Australia and abroad with some success. Now, challenge for decision makers in a city like Cairns is among all these different solutions that are available, how do we know which one will work for my city? There's no solution, there's no single solution that fit every city and every area. Therefore, we need a suite of solutions. And the other challenge is how do we create an evidence about these solutions that and where it will work and where it will not work, and how do we make that evidence-based decision? Heat is an emerging hazard. We make our planning decision about all other natural hazards based on evidence. We build flood models, coastal hazard models, and make our planning decision based on that. But are we doing same for heat? The answer is probably no. To help make evidence-based decision, in this project we have developed a decision framework which allowed us to create evidence about suitability of different heat management solutions at different geographical scale. The first level, as you can see in this inverted pyramid, is understanding heat wave risk at a city scale. So this basically looks into the emergency management response and its effectiveness during a heat wave. things such as, will my critical infrastructure such as power, telecom, water, hospital work during heat wave? Do our community know what to do during heat waves? Do we have an out refugia, so on and so forth? I want to talk about that in today's work because that Sue Campbell and others are doing a lot of work in that space. Our work was mostly focused on the second level down, which is conducting an opportunity assessment at a city scale to understand which is the most vulnerable hotspot and what is the best opportunity to make improvement within the city. And then once we know which are the hotspots, then zooming down within those hotspots to develop high resolution microclimate simulation and test different effectiveness of different heat management solution within those areas. Let's look at how we applied the second tier of the decision framework in Cairns CBD area. So first of all, why do we need an opportunity assessment? Opportunity assessment allows us to identify vulnerable hotspot within the city area so that investment decisions can be prioritized. In Cairns City, we looked at a number of evidence to understand vulnerable hotspots. Obviously, temperature distribution is a key evidence which shows that the areas in the industrial areas in the southern side has elevated temperature compared to the other areas, and it is highly correlated with the presence and absence of vegetation in city. And also it is important to understand that our elderly and younger population are more sensitive to heat. Therefore, we need to identify where those demography predominantly lives. And also lower socioeconomic profile people, which is captured by SAFE index, are often has less capacity to deal with heat waves. Often they live in rental houses so that they have limited capacity to make any changes to those built environment of those houses, limited capacity to afford the aircon, and often they live in older houses which has less insulations. So once we capture all this evidence together, we start to see the emergence of a vulnerability hotspot within the city, which provides us the opportunity corridor where investment decisions can be prioritized. Once the vulnerability hotspot mapping are conducted at a city scale, next step is to zoom into one of those vulnerable hotspot at a neighborhood scale and start understanding what can be done to improve thermal condition within those areas. In that respect, in this project, we have done a number of things. One is that Cairns Council, in collaboration with James Cook University, had installed a number of temperature sensors throughout the CBD area. In this project, we have analyzed those temperature data to understand whether the policy implementation that has been happening in the CBD area in terms of plantation and beautification work, is it providing any temperature benefit? Also, other thing we do in that neighborhood scale is that we developed a number of microclimate simulation scenarios for CBD and tried to understand what is the optimum arrangement of different heat management solutions. And I'll talk about both of them in a sec. So let's first look at what we did in the analysis of temperature sensor data. So in last few years, Council has been implementing significant tree plantation work in the CBD area, which is reflected in this map, which is the difference of NDVI between 2020 and 2018. So the areas that is marked in green shows there is an increase of health and amount of vegetation, and areas which are marked in brown has lost vegetation. So if we look in this block of CBD area, that's where Council has installed about 95 of their sensors. So we looked into those 95 sensor information, and only fifth of them was usable due to different reason. And using those about 15 to 20 sensors that in that area, we tried to understand what was the difference of temperature between 2018 and 2020, so that we can start to identify if there is any signal of temperature improvement due to tree plantation that council has been doing. So we found that on an average 2020 November was 1.5 to 5 degrees cooler than 2018. Now 2018 was a exceptionally hot November, and on an average it was about 2 degrees higher than the normal average. So even if we take that 2 degree out of the data set, we can see a cooler 2020 November compared to 2018. And then in that case, it is highly likely that due to these new tree plantation that has been happening in CBD area might have resulted in that reduction of temperature in November. Next thing that we did for the CBD area is to create a number of microclimate simulation models so that we can start understand what are the optimum heat management solutions for the area going forward. So microclimate simulations are a high-end computational fluid dynamics model that allows us to mimic the processes that happens in our built environment, such as heat transfer between atmosphere and buildings and soils, trees, and it captures all the minute and small processes that results in a certain type of thermal condition in a city. The first step of building a microclimate simulation model for Cairns was to develop a digital twin of CBD, where we incorporated different information such as building footprint, height, road pavement, vegetation, and topography of the area, and created a 3D grid. A number of councils' data has informed this model development, such as building footprint, tree canopy layer, and the road layout, and so on. Building height information was sourced for a third-party commercial source. Once the model is developed, we run the model and start seeing the results that you can see in the slides. The first one is showing the temperature distribution on a hot summer day in a CBD area. And the second one is showing a bit more detailed information, which is known as physiological equivalent temperature, PET, which is a measure of outdoor thermal comfort, which combines not just temperature, humidity, wind speed, and radiant heat. And the areas which are shown here in blue has higher thermal comfort. That means people feel less exposure to heat in those areas compared to the areas which are shown in yellow. So that gives you an evidence to target where the next round of improvement should be made, where you should be targeting your tree plantation in future, or where you should be targeting your next round of implementation of shading. Once the microclimate simulation of present day are developed, then we run a number of what if scenarios. There are three scenarios that we run. One of them is short-term low cost, which are just addition of trees in CBD areas. Second one is mid-term moderate cost, where we can try cool roof in some buildings and cool pavements in some areas. And the scenario 3 was a long-term high cost, where we have road shading structures, cool roof, and trees and green roof in implement. So this is an example of scenario results output. The first image is showing a present day scenario of thermal comfort distribution across different areas. The second one is showing the results of scenario 3, where we added a shading structure in the Grafton Street similar to this one, and added some green roof and planted some trees in targeted areas, which is showing a improvement of thermal comfort conditions in Grafton Street and some of the nearby areas where walkability of tourists and local businesses are really important. So once we simulate all these different scenarios, finally we need to think about what would be the pathway of implementing these options as a heat management strategy. So we developed this broad heat adaptation pathway for Cairns CBD area, where x-axis is showing different climate future, y-axis is showing different types of options that we could think of, and the length of these bars is showing when these options can be effective, and the color of them are showing their cost. So as you can see, regardless of which option we implement in future, emergency management response and community awareness and resilience to heat has to be there all along. These are very critical. Planting trees can work, and it's a low-cost option up to a near term, but after that we will need different other solutions, different urban planning measures, and some of the traditional solutions such as shading structure, water sensitive urban design features. And as we move towards near to midterm, we will need to start implement some of the innovative engineering solutions such as cool roof, cool pavements, and some of the other solutions that will be emerging going forward. So in summary, the evidence that has been created in this study can be used to underpin any future decision making in the CBD area to improve thermal condition. And it's important to note that this was a pilot study conducted only in CBD area, focusing in areas where a lot of tourist activity happens. But this type of study is really critical to apply also in areas where bigger community of Cairns lives, which is outside CBD area. So it is really important to replicate this study in other part of Cairns. That's it from me. If you have any question, feel free to contact me and I'll be happy to answer any questions. Thanks for this opportunity. Bye.